of the operational amplifier is power supply rejection ratio. Power supply rejection ratio. Here two power supplies are there, plus VCC and minus VEE. Consider input offset voltage VIO at negative terminal of the op amp, that is inverting terminal of the op amp. Positive terminal of the op amp is connected to ground. Uninverting terminal of the op amp is connected to ground. Two ways are used to define PSRR, power supply rejection ratio. First one is VCC changes, VIO changes, V is constant. Second one is VE changes, VCC is constant, VIO changes. Therefore, power supply rejection ratio is equal to power supply rejection ratio is equal to change of input offset voltage with respect to change of VCC. VE is constant. VE constant. Second one is PSRR is equal to change of input offset voltage with respect to change of VEE, VCC constant. Practically, the units of PSRR is millivolts per volt, both are in volts, or microvolts per volts. That value is 30 microvolts per volts for IC 741. For IC 741. Ideal case that power supply rejection ratio value is 0. Practical case, some value is there, 30 microvolts per volts for IC 741. Coming to next one is differential amplifier. Differential amplifier is the basic building block of the operational amplifier. Stage 1 and stage 2 of the operational amplifier are two differential amplifiers. First differential amplifier is double input, balanced output configuration. Double input, balanced output differential amplifier configuration. Differential amplifier configuration. Second one is double input, unbalanced output differential amplifier configuration. Double input, second stage of the operational amplifier is double input, unbalanced output, unbalanced output differential amplifier configuration. Double input means two inputs is applied to two transistors, and balanced output means the output is taken across the two collector terminals of these two transistors. Double input means two inputs, and unbalanced means the output is taken across one of the collector terminals. These two are the two input stages of the operational amplifier. Consider ideal differential amplifier here. V1, it has two inputs. One output means the dual input or dual input, unbalanced configuration differential amplifier. V1 is the voltage applied at the positive terminal of the op amp. V2 is the voltage applied at the negative terminal of the op amp. Speed is the difference between these two voltages. The ideal differential amplifier is used to amplify the difference between these two voltages. Therefore, output voltage V0 is equal to Vd into the output voltage V0, directly proportional to V1 minus V2. eliminate this proportionality, we use proportionality constant. V0 is equal to AD into V1 minus V2. Where AD is called as a differential gain, V1 minus V2 is called as a difference signal. This one is a difference signal. This one is a difference signal. AD is called as differential gain. AD is called as differential gain. V0 is equal to AD into V1 minus V2. Generally, gain AD is equal to differential gain of the differential amplifier is AD is equal to V0 by output voltage by input voltage. Therefore, V0 is equal to AD into VD. Here, D suffix means input to the ideal differential amplifier is difference signal. Difference signal, that is the reason the gain is called as a differential gain. The gain of that differential amplifier is called as differential gain, differential voltage gain. V1 ideal case, V1 both are DC values. V1 is equal to V2, V0 is equal to 0. Ideal cases are not possible. Some output voltage is there. In second case, instead of difference signal, we use a common mode signal. Difference signal means VD is equal to V1 minus V2. Common mode signal is VC is equal to average of these two voltages. Average of these two voltages applied to this ideal differential amplifier circuit. Therefore, output voltage is in the similar fashion. Instead of AD, we use AC because common mode signal is applied. AC into VC. Here, input to the differential amplifier is a difference signal. Therefore, output is equal to V0 is equal to differential gain AD times difference signal V1 minus V2. And similar to the input to the ideal differential amplifier is a common mode signal. VC is equal to average of these two voltages. Therefore, output voltage of the ideal differential amplifier is that gain of the common mode gain of the differential amplifier AC into common mode signal. Therefore, total output P0 is equal to AD VD plus AC VC. AC VC is the undesirable one. AC VC is the undesirable one. AC should be 0. Is common mode signal gain should be 0 because that term is related. AC is related to noise signals which are applied to two inputs of the differential amplifier. Two inputs of the differential amplifier. AD VD is the desirable one. AD is high value, AC is low value. VD is equal to V1 minus V2. AC is V1 plus V2 by 2. V1 is equal to V2. Suppose V1 is equal to V2. No doubt this one is 0. VD is equal to V1 minus V2, 0. But AC, VC term is present. VC is equal to V1 plus V2 by 2. That is AC into V2 V1 by 2 means V1 or 2V2 by 2 means AC into V2. When input voltages are equal, the term is 0, but some common mode gain and some voltages either V1 and V2 noise, these two are the noise voltages are present at the output of the ideal differential amplifier. That is the reason this term is undesirable one. This term is undesirable one. By considering this concept, we have to define common mode rejection ratio. Common mode rejection ratio means the ability of the differential amplifier eliminate this common mode signal is called as the common mode rejection ratio. CMRR is referred as the ratio of AD by AC. The ratio of AD by AC. AD is high value, AC is low value. AD is high value, AC is low value. Ideal case, AC is equal to 0. Therefore, AD by 0, that means infinity. Common mode rejection ratio in a ideal case infinity. Practical case means high value. Practical case means high value. CMRR is measured in dB. CMRR is measured in dB. 741 CIC, that value is 20 dB. Precision 741 CIC, that value is 90 dB. 90 dB. One. Common mode rejection ratio. The ability of differential amplifier to reject common mode signal is expressed by a ratio called common mode rejection ratio, denoted as CMRR. It is defined as the ratio of the differential voltage gain to common mode voltage gain. Rho is equal to 85 AC. We know that output voltage can be expressed in terms of CMRR as below. V0 is equal to, we know that AD, VD due to differential signal, AC, VC due to common mode signal. Common term is AD, VD, 1 plus AC, VC by AD, VD. That is equal to AD, VD, 1 plus VC by VD, 1 by AD by AC. AD, VD, 1 plus, this is the common mode rejection ratio, VC by VD. Common mode rejection ratio is infinity, high value. Therefore, output voltage is equal to 1 by infinity is 0. This term is 0. The output voltage V0 is equal to AD into VD. This is the expression. Common mode ratio rejection. Here, the input to that differential amplifier is common mode signal. That is, VC is equal to V1 plus V2 by 2. Common mode gain is very, very important. That is AC. If we apply two input voltages which are equal in all respects to the differential amplifier, that means V1 is equal to V2, then ideally the output voltage V0 is equal to A V1 minus V2 times AD must be 0. V1 is equal to V2 means V1 minus V1 into A, that is 0. But the output voltage of the differential amplifier not only depends on the difference voltage, that means V1 minus V2, but also depends on average common level of the two inputs. Average common level of the two inputs means common mode signal. Such average level of the two input signal is called as common mode signal. That is VC. VC is equal to V1 plus V2 by 2. Practically, the differential amplifier produces output voltage proportional to such common mode signal. Output voltage is proportional to such common mode signal. Eliminate this proportionality, we use proportionality constant. V0 is equal to AC into VC. AC into VC. This is the expression. The gain with which amplifies the common mode signal to produce the output is called as common mode gain of the differential amplifier, denoted as AC. The gain with which amplifies the common mode signal, that is AC or VC, to produce the output V0. To produce the output is called a common mode gain of the differential amplifier, denoted as AC. There exists some finite output gain AC in case of practical differential amplifier. Here VC is equal to V1 plus V2 by 2. V1 is equal to V2 means 2V1 by 2 or 2V2 by 2. Some output voltage is there. Therefore, the total output of any differential amplifier can be expressed as V0 is equal to AD/BD plus AC/DC. This is the theory related to common mode signal. This is a theory related to differential signal. In case of differential signal, we have to consider differential gain, AD. V0 is directly proportional to difference between these two input voltages, V1 minus V2. Eliminate the proportionality constant, we use AD. AD is called as differential gain. V0 is equal to AD into VD. Therefore, AD is equal to V0 by VD. Then V0 equal V0 by V1 minus V2. V1 is equal to V2. Therefore, V0 by 0, that is infinity. Ideal case, AD is infinity. Ideal case, AC is 0. There is some important parameters explanation. Features of a differential amplifier are high differential voltage gain. AD is high because AD is equal to V0 by V1 minus V2. V1 is equal to V2, V0 by 0, that is equal to infinity. Low common mode gain. AC is low common mode gain because generally this common mode signal is not appear. But consider this common mode signal is also, because this common mode signal is related to common noise is applied to both input terminals of the op-amp. That is undesirable one. This gain means AC increases means this noise signal is also increases. That is not a desirable one. That is the reason AC must be decreases. Therefore, common mode signal is eliminated. Low common mode gain, high CMRR. Rho is equal to CMRR is represented by rho is equal to AD by AC. AD is high value, AC is low value, rho is high value. Or AD is high value, AC is AD by AC is 0, that is input. Two input terminals. The differential amplifier has two input terminals. These two input terminals are under open circuited condition, therefore high input impedance. The first stage and the second stage of that operational amplifiers are the nothing but differential amplifier. First stage is the dual input balanced output differential amplifier configuration. Second stage is the dual input unbalanced differential amplifier configuration. Why two stages will require? First stage is not enough to provide high gain. That is the reason cascaded second stage is also used. Direct coupled cascaded second stage. By using these two stages, the gain of the operational amplifier increases. Large bandwidth. Large bandwidth is used to amplify zero signal frequency to high frequency. Zero means DC signal to high frequency. Low offset voltages and current. Low offset means VIO, VOO, and currents means IIOS and IB, bias currents. Low output impedance. Output impedance must be 0. These are the two important parameters are related to op-amp. First one is power supply rejection ratio. Second one is common mode rejection ratio.